All right. In this section 3.2, we're going to explore graphing linear equations in one way. As we go through chapter 3, we'll see a different way to graph linear equations, but this way is a good way to start. So we looked at an equation in 3.1 that looked a little bit like y equals 2x minus 3. Right? And we wanted to find solutions to this equation. So you can find solutions just like we did before with a little chart. And you can just pick values of x that you'd like to use. So if I want to use 0 for x, right, it's always a good idea to start with 0. It's a very helpful number when we substitute it in. You can see if we substitute 0 in. When we substitute 0 in for x, that'll make this guy disappear. 2 times 0. So we'll end up with 0 minus 3, which will be negative 3. So the y value is negative 3. Here's a solution. We found one. And if we want to graph a line, right, we need at least 2 points to graph a line. But in this section, we're going to make sure we find 3, because if we can find 3 points and we can plot them on a graph, and they all make a straight line, then we can be very confident that we have the correct line graphed. With 2, you could have made a mistake. So let's try to get 3. All right, we can pick any other value for x or for y, just like we did before, and substitute it in the equation and see where it goes. I like to pick small numbers to deal with, so I'm gonna deal with 1 here. So let's try to find another solution where x is 1. So I plug that in, y equals 2 times 1 minus 3. Y equals, this will now be 2 minus 3. Y equals a negative 1. All right, so when x is 1, y has to be negative 1 to go with it, and that'll make a solution for our equation. And let's just find one more. This time, I'm going to pick a value for y, just to show you that it doesn't matter. You can pick a value for x, a value for y. It's kind of open-ended in that regard. I'm going to pick 0 this time for y. Nope. I want to pick 1 for y. All right, so if we substitute 1 in for y, we have 1 equals 2x minus 3. All right, this gives us an equation that we have to solve, and it requires a little bit more work than substituting a value in for x in this case. Right? But we can still solve this. So we can add 3 to both sides. To cancel out here, we have 2x equals a positive 4, and divide by 2. And the x value that would work out here is an x value of 2. So when y is 1, we need an x value of 2. Right, and as a challenge, right, I'm going to let you substitute in a 0 for y and see why I didn't want to do that. If we do this, right, sometimes you run into situations where you solve the equation and you end up with an answer that's a fraction or a decimal, and it's not so easy to plot, especially on MATLAB. So right, I opted not to do that, and you can check on yourself to see why. Right? So if we had these 3 solutions that we came up with, right, let's take these and put them on a graph. All right, so again, all right, x coordinate, y coordinate. This creates 1 point where x is 0, y is negative 3. We have 1, negative 1, so our x is 1, y is negative 1. And 2, 1, x is 2 and y is 1. There we go. All right, so if you had a good graph drawn out, these 3 points should look like we can connect them. right, and a nice straight line. Right, so hopefully your line looks like that as well. Right, and that's how we can graph any line. Right, we can start plugging in numbers, substituting in for x or y. It doesn't matter. We can find the missing piece. Right, we find a few points, graph them, and we have a representation of our line. Right. Right, let's take a look at another quick example. Right, just to give you a hint, or a little trick that might help out in a more tricky scenario. If I've got the equation y equals 2/5 x, let's call it negative 2/5 x plus 1. Right, this equation looks more intimidating. It's got the fraction in here. Right, but we can still attack it the same way, right, by picking values of x or y, whichever one we want to deal with. But we can pick these values strategically. It's up to us. I mean, we can pick whatever we want, but we can pick x's so strategically that we can kind of cancel out this fraction and not have to deal with it. And so what I mean by that is, well, let's start by picking x is 0. You can see why this is going to be really nice to start off with a lot of times. And if we have y equals negative 2/5 times 0 plus 1. Right. Well, anything times 0 is 0. Right. So this is gonna, the fraction's gonna go away. We've got 0 plus 1, y is 1. Okay. 0 is super nice to use. So I would always start with this. Okay. Next, a nice way to handle a fraction, if we're going to find solutions this way, right, is to use whatever the denominator is as your value of x. And you can see why in a second. So I'm just going to write down, use the denominator for x. This is a good little trick. We substitute in 5 now, and we're going to have y equals negative 2/5 times 5 plus 1. All right, remember, if we're multiplying any number times a fraction, we want to think of it as a fraction as well, because we're going to multiply numerators and denominators together. You can also do some simplifying here, and this is the key point. Why did I choose 5? Because the simplifying is going to be ideal. Right? The numerator 5 will cancel with the denominator 5. Right? So all we really have is negative 2/1, right? Which is just negative 2. Right? Negative 2 plus 1 will be negative 1. So the appropriate y value here would be negative 1. There's 2 quick solutions. And you could even do this one more way. If you wanted to pick another denominator that would work out nicely, well, let's use negative 5. And if we use negative 5 here, I think I got some space here. Y equals negative 2/5 times negative 5 plus 1. Right, here, same idea is going to happen. Think of this as a fraction. We can cancel out numerator and denominator. Right, but this numerator will still stay negative. It'll still be a negative 1 up there. Right, so in reality, we have negative 2 times negative 1. That'd be a positive 2. 2/1 is just 2. 2 plus 1. And we get a y value of 3. Right. We've got 3 quick solutions. We use this little tip to help us find those solutions to avoid having to deal with that fraction or deal with any nasty numbers. So we can plot these 3 on a graph and have the appropriate line. 1, 2, 3, 4, 5. Right, so there's a little graph. Right, 0, 1, this first point that we found. Right, whenever we use x as 0, we're going to find this point that falls on the y-axis. Again, that's the y-intercept, so we found the y-intercept first. 5, negative 1, so x is 5, y is negative 1 right down here. And negative 5, 3, x is negative 5, y is 3 up here. Pretty far apart, but looks pretty good to me. And we could connect these three with a straight line. There we have it. So that line represents all the solutions to y equals negative 2/5 x plus 1. Okay. So there's our main type of problem from 3.2, and this is going to work for any type of line. Is you can pick your values for x, your values for y, find those solutions, and graph.